Hello, everyone. Good morning, good afternoon. Welcome to another episode of IBM Expert TV. So today's focus would be on managing enterprise container workloads. So my name is Leo Christie Jesuraj. I'm a developer advocate and a team lead. I work with the WebSphere containers and operators within the IBM automation organization. All right. So previously we had a session on running Liberty in containers. So if you haven't caught the replay of that, I will include a link for you to check that out. But for those who hasn't, who weren't able to join, here are some recap, which will set the stage for today's topic on managing the containers in a cloud environment. For Liberty, we have a various set of images that we provide. So this allows you to build your application images using this as the base. So we have the Open Liberty as well as the WebSphere Liberty over here. We have different Java options, the IBM Java that adopt OpenJDK with OpenJ9, which is our recommended option, as well as we have various operating systems, so including the UBI as well as the Ubuntu. And at all times, we have the images available for the last three versions of Liberty. So that's the monthly driver, the latest monthly driver, plus the last two quarterly releases, which are the long-term supported releases. And in terms of the image, there are a couple of tags that we have. So we have simplified this. So to just have two tags now. So there is the kernel slim for Open Liberty, and then there's the kernel for the WebSphere Liberty. Then there is the full, which provides all the features. For production, obviously, we would recommend you start with the kernel slim and grow your image as per the application needs. So that will keep the containers small with just only the things that you would need. So our images are available in Docker Hub as well as the IBM Cloud Container Registry. And they are certified by Red Hat, so it conforms to a lot of the best practices, and it's secure. So you can be rest assured that they're ready for production use. And they also, if you have support from IBM, they will be fully supported on any of these platforms. All right. Then, in addition to Liberty, we also have the base image for TWAS, or the traditional WAS. So depending on the applications that you have, some of them may not be, you may not be able to move them to Liberty. Maybe they're too complex, or they only be there for a few more years, and you don't really want to invest in re-architecturing it entirely, and you just want to continue to run on TWAS. So for that purpose, we have the TWAS base. Note that it's not the ND, because the ND capabilities will conflict with the Kubernetes model. So you may need to do some operational modernization, as we call it, to get it to run on TWAS base. And once you do that, you should be able to build your application images using this base image that we provide. All right. And then here's a quick recap of some of the best practices that we covered in the last session. Here's the link for that session if you're interested to check it out later. Yeah, so some of the main things are like the container should always be immutable. So it's a bit different from the VM world, where you deploy things and configure them later. With containers, it's quite the opposite. You should always, as you are building the image, you should configure them. The only exception to this rule is environment-specific values that needs to be injected into the containers. These containers, as we will see in today's presentation, that they need to be orchestrated, they need to be managed, and as part of that process, these containers can be taken down at any time and replaced with another instance. So for that purpose, the container should be stateless, meaning you should store any important data outside the container by attaching persistent volumes. And yeah, some of the other best practices, such as you should only package one application per container. So that really makes it easy to deploy them, scale them up and down. And you should always properly tag and label your images. The non-root, that's obviously for secure purposes. As your container is running, you want to run them as non-root. The Liberty images that we provide are already configured for that, and they would only run as non-root. And the other thing to keep in mind as you're building the application images is to pay attention to the Dockerfile instructions to keep the container size as small as possible. So I just quickly went over it, but if you're interested, please check out this previous session. All right, so that's some introduction on the container images that we have for Liberty. And when it comes to application images, we recommend this approach where you build your own enterprise base image. So you would start with our certified image for either Open Liberty or Webster Liberty. And then this is where you can add best practices for your enterprise, whether it's related to compliance or security, that all application developers within your enterprise should obey by. So you can put these things in this base enterprise image. So this mainly brings the consistency across the enterprise. So everyone is starting with the base image that is blessed by the architects within your enterprise. But then it also has a lot of performance advantage because, as you know, the Docker has this layering, caching layer mechanism. So if all the application images are using this common base image, let's say you are running like hundreds of application in an environment, then only the first application would actually push the entire stack of layers, and after that it would be just the application itself and the configuration for that particular app. So you would see a lot of performance improvement into when you, for example, when you're trying to push an image into the repository, it would be much faster after the first app. All right. The other thing to keep in mind as you're building your application is to make use of programming models that are available to you, because, as you know, these applications would be running inside a container, and they would be managed by like orchestrators such as Kubernetes, which we will talk shortly. So these programming models are there to basically to bridge the gap between the two, the container and the orchestrator. So with Open Liberty, you have the option to use microprofile. So we have some integration already built within the images that we provide. So one of them is the microprofile config. So obviously, as we talked about, you would have these containers running in many different environments, and you want to be able to inject any environment-specific values at runtime. So microprofile configs allows you to easily do that. And in a Kubernetes environment, these values can come from config maps or secrets. The health check, that's very important because your container will be managed by this orchestrator and not an individual. So it's very important to specify this health check because as the application owner, you know the state of your application when it's healthy and when it's not. So microprofile health check, it's a framework that allows you to easily define that health logic. So these orchestrators will continuously check the health of the containers and take necessary action. For example, taking down the container and restarting it, hoping that will resolve the issue, or it can stop the traffic to that particular instance of the container. And then there are also microprofile metrics, which helps to improve the performance of your application. You can gather data and see which part of the applications can be optimized. And then there's also Open API. It allows you to discover APIs that are available to you, as well as document your APIs in a consistent manner. All right. So you should always look to, if you are refactoring your applications, consider the microservice architecture and using these microprofile specifications. All right, so let's move on to today's main topic, is on container orchestration. So we talked about containers in this episode and the previous episode. So containers are great. We talked about the best practices and so on. But as you would quickly realize, as you have like more and more applications, you will quickly get overwhelmed with the management aspect of these containers. So the containers alone are not enough. You need an orchestrator to manage these containers, because you don't want to do that manually yourself. All right. So that's where Kubernetes comes in. So it's a open sourced project that has been adopted by a lot of vendors, as well as customers and enterprises. So if you look at it basically helps. It helps to manage these containers. So it has a lot of standard capabilities that you would expect from something like this, such as horizontal scaling, meaning you want to scale your applications as per the either manually or as per automatically, as per the CPU or memory usage or the traffic. You want to be able to have like multiple instances to handle the traffic. And then Kubernetes is self-healing, so we touched on the container health. So depending if a particular container is not healthy, then it can take down the container and replace it with another instance, and it can block the traffic from getting to that particular container and redirect it to another instance. So it has a lot of self-healing capabilities built in. It's all automated. And also when it comes to applications, obviously you would have like different versions. So that means these containers needs to be upgraded. So Kubernetes also has built-in mechanisms to help with that. You can define the update strategy. You don't want to take down all the instances of the containers at once, because then there won't be any containers to serve the traffic. So it can do that incrementally. It can monitor the state of those upgraded containers, and if things go wrong, they can automatically roll back those upgrades. Then we quickly touched on config maps and secrets. So it has the capability to store these sensitive information and inject them safely into the container. All right. And the other thing is the service discovery. So meaning you would have like multiple instances of these containers, and but you want to the Kubernetes will manage the load balancing between those instances. So you just create a service that would be the front accepting the traffic, and underneath each of the container or the pods will handle the traffic. Right. So one important aspect when it comes to Kubernetes is it's a bit different. It's not the traditional way of deploying things. So typically you would write scripts to accomplish like the deployment. But Kubernetes is a bit different. Instead of telling Kubernetes how to do something, you just tell it what to do. So it's more of a declarative specification. So for example, this is a deployment definition. So here you're saying, I want to have 2 instances of my application running, and here is my application image, and the image pool policy, and port, and so on. So you're basically defining the state that the application should be in. So I always compare this to like a smart thermostat. You don't tell it how to maintain a particular temperature. You just set the temperature and let it do its thing, right? So depending on the weather, it will either turn on the AC or the heater to maintain that state. So Kubernetes is doing something similarly. So as a user, you are declaring the state that needs to be maintained, right? So if you're not familiar with Kubernetes, yeah, so here are some of the core resources. So there is the namespace that's there for providing isolation. You may have different users or a group of users within a single cluster. So namespace allows to provide role-based access and that isolation that you would need within an enterprise. So we talked about containers running in containers. So pod is the smallest deployable unit within Kubernetes. So all these containers would be running within a pod. Typically, it's recommended that you deploy only one container per pod, unless the only exception to that rule is the sidecar approach. Sometimes you want to have additional containers running alongside that main application. So that is the only exception, meaning the additional containers will support or enhance the main container. Otherwise, you should always deploy one container per pod. So the pod itself is not something that you will create directly. You can, but you shouldn't. You should use the deployment to define. So that allows you to easily scale up and down, right? Then we talked about the config map for storing configurable information, and these can be read and injected into the container, or they can be mounted as a volume into the container. So as the container is running, your application is running within the container, they can read these information. And then secret is similar to that config map, but it's there for storing sensitive information like passwords and so on. And we talked about service, so it's there for load balancing. So it sits in front of these set of pods, and it manages the traffic. And there's also ingress and route for exposing your application outside the cluster. So think of it as a proxy, right? So these are some of the Kubernetes, the core Kubernetes resources. All right, but so we talked about containers, which is great. Then we just talked about Kubernetes, but it's still not enough, because when it comes to an enterprise where you have multiple teams collaborating on many different applications, you need more of a platform. So you need integration, collaboration, like logging, monitoring, and so on. So you basically need a platform that provides all these capabilities. So that's where OpenShift comes in. It's enterprise-ready Kubernetes. It's built on Kubernetes technology, but it has additional advantages. So it's first of all, it's very secure. So all the containers by default, they all run as non-root and random users. So that really makes the containers very secure. Then it also provides advanced UI and command line interface. So that allows you to easily interact with the cluster and accomplish tasks much easier. Then in addition to Kubernetes, what Kubernetes provides, OpenShift builds upon that. So it has this route instead of the Kubernetes resource ingress. So it makes the exposing your application outside the cluster much easier. Then also OpenShift has this ImageStream concept. So we talked about upgrading your applications. That means you would need to build different versions of your application images, and these needs to be pushed to our image repository. And OpenShift comes with a repository that you can store these images. And ImageStream is a concept related to that. So as soon as you push a new version of your container to a particular image stream, that can be consumed by the various tools that are running in the cluster. So we'll talk more about that when we talk about the operators. Apart from that, again, we'll talk about the operator. So that's something that's integrated within OpenShift. And on top of that, OpenShift also provides like pipelines for DevOps and service mesh and serverless concepts. So these are all built upon and available to you within our OpenShift container platform. OpenShift, this is referenced by OCP. It also is built on an OpenShift project, open source project called OKD, or the origin. So if you are just interested to get started, you can just get the command line tool and just run a small cluster right on your laptop. So if you have used Minikube in the past, it's similar to that, but it's available there for you to just get started on. All right. Okay, so that brings us to the operators. So we talked about all the different capabilities that OpenShift provides. One interesting aspect of that is a lot of the things that the OpenShift does, it does through various operators. So operator is basically an extension of Kubernetes. So just like we talked about the various Kubernetes resources and how Kubernetes manages them. So it's operator is an extension of that, meaning that you or vendors can define their own custom resources and provide these operators that will manage those custom resources. So the advantage of this is not only just packages and deploys your application, but it can continuously monitor them because it's running within the OpenShift cluster itself. It's not running elsewhere. So it has access to all the events that are happening within the cluster. It can respond to any user actions, such as creating a new object or changing the configuration. So it's just running inside the cluster and looking over your application and taking the necessary action. As we talked about the declarative approach, you can define what your custom resources needs to do, and the operator will do the necessary, it will take the necessary actions to accomplish and maintain that state, right? So it's a little program that's running inside the cluster and looking over your application. So here is why you would need an operator. So we touched based on some of the core Kubernetes resources, but that's not all. There are so many other resources, and Kubernetes is very hard to learn. So there is a steep learning curve. So if you are to create these resources yourself, you need to know about each of them, and you need to deploy a particular application. You would need to create multiple of these resources to accomplish the deployment of the app. And again, within the enterprise, different teams or different folks may try to do this differently. So it will bring inconsistency in the way these applications are deployed and managed. And the other thing is, as your applications are running, things may change, like database password, it may change. New services, they may be available, and you need to find them and bind your application to that. You need to do like data operations. So it's a lot on you to create these resources manually and manage them. And that could be a daunting task for someone who's not even familiar with Kubernetes in the first place. So that's where an operator comes in. So instead of having all these different resources and having to create and manage them yourself, you just create a single resource or handful of resources to accomplish the same task. So in this case, I'm showing a custom resource called Open Liberty application. So it's a custom resource, and there's an operator associated with that called the Open Liberty operator. And it basically solves the problems that we just discussed. So it will keep, first of all, it will make it easy for someone new to get started. But even advanced users can configure it according to your needs to accomplish the deployment and the management of your applications easily to our OpenShift or Kubernetes environment. And since you are using this custom resource, it will bring consistency in the way the applications are deployed, the many different applications within your enterprise. All right. So where does the operator comes into play? So you would have your application code, and then you would need to build them. So you can follow different ways to build them. You can use a multi-stage approach, or you can use build config or source to image. So it doesn't matter how you build your application image. Once you may have a pipeline set up to do that and make that application image available to the cluster. And as soon as your image is available, then the OpenLibrary operator, for example, here can be used to deploy this image into the cluster. All right. So here is another example of how that will look like. So once your application is, again, it doesn't matter how your application is built. You can deploy that with the OpenLibrary operator, and here is a sample snippet of how such a custom resource will look like. So OpenLibrary application, that's the custom resource name. And here you are just saying, hey, this is my application image. I want to have a service, and I want to use this particular port. I want to expose my application outside the cluster. And I also want to persist the logs at this particular location. And that's all you need to do. And behind the scenes, the operator will go and deploy this application. It will create the service. It will create the route for you to expose this. And it will also create the persistence volume claims that are necessary to persist this particular data. So all that can be just done by this single resource without you having to do all those manually. And the other thing is operator also will continuously watch these resources that the operator created. And if anything gets out of sync, or it's different from the state that you describe, it will take the necessary action to maintain that state, right? All right, so moving on. So here are some of the highlights that OpenLibrary operator operators functionalities. So first of all, it's available in the operator hub. So think of it as the app store for operators. And it's certified with the highest maturity level, meaning it does a lot of different things for the custom resources that it manages. All right, and yeah, apart from the typical scaling and other things that you would expect from for your application, there are also integration, for example, for monitoring. Or for managing or injecting certificates to protect your application. There is an integration with the cert manager. And we talked about the routes, exposing it, but then there's also, you can do that securely using TLS. Then we touch based on the volume and persisting. So all that can be easily accomplished with a few lines of definitions and YAML. And apart from the standard things that you need for your application, it also has some day two operations for gathering, like, for example, trace and memory dump from an application that's running inside a container. So I'll have some examples at the end to show how that looks like. All right. And then we are also working on, or we are planning to work on many different features that are highlighted here. So some of the service mesh and transaction helper and so on. All right. So just some background information here is that OpenLibrary operator is built upon this other operator called Runtime component operator. And on top of that, OpenLibrary provides OpenLibrary specific capabilities. But there is also this runtime component operator that if you are looking for deploying applications that are built on different frameworks, that this particular operator is also there. So regardless of the runtime underneath it, it can manage that. But if you're using OpenLibrary, then obviously you should be looking to use the OpenLibrary operator. So we manage both of these operators. So it's built on top of that. So all these capabilities that are highlighted in the red, it's coming from the runtime component operator, and anything specific to OpenLiberty, for example, the single sign-on capabilities that are provided by OpenLiberty, it's all part of the OpenLiberty operator. Right, and yeah, so if you're using OpenShift, this operator is certified and it's available through the operator hub that's available inside your cluster. But if you are looking to deploy that to another Kubernetes cluster, then we also have the necessary information in our GitHub repository. So this should be the main link that you go to check out this operator. All right. All right. So we talked about the day two operations. So you can either use the OC CLI tool or the OpenShift UI. And using the operator, you can gather the trace or the dump. It's very trivial to do this on a Liberty instance that's running outside of containers. But when it comes to container, that's running inside a pod and that's managed by deployment, it's not so straightforward. So for that purpose, we have created two additional custom resources that are called OpenLiberty Trace and OpenLiberty Dump that will help you to gather this information and store that into a persistent volume that you attach. All right, so here is an example of the trace operation. So all you need to do is just go and create this OpenLiberty trace. You just put the name of the pod that you want to gather, enable the trace on, and you specify the trace specification. So that's the Liberty trace specification. And optionally, you can specify like the number of files and the size of each file and so on. But once you do that, it will the operator will go and enable the trace on that particular instance of your application, and you can go to the volume that was configured to get that information. And similarly, for the dump, there is another custom resource. So once you have the instance of the pod that you want to operate on, you just provide that to this OpenLiberty dump custom resource. And you can specify whether you want the heap dump, the thread dump, or the system dump, and it will go ahead and create that that for you. And here you can see the status of this particular data operation. It says it started, and shortly once it completed, you should get this status. So that's some introduction onto the operator. And within the operator hub, there are many different operators available from many different vendors. So I would highly recommend you to check out the OpenLiberty operator as well as these other operators that are available in the operator hub. So the last time I checked, there are well over 200 plus operators and more from IBM as well. So depending on what you want to do, whether it's application deployment or whether it's related to database or monitoring or security or storage. So there are various operators that are available. That really makes it easy for you to configure and deploy and take advantage of these various products and tools. So it's a way to bring in additional capability into your OpenShift cluster. So as I said, it's like an app store for operators. So you just, with a couple of clicks, you can install them, and then you just create the necessary custom resources to accomplish what you want to do. All right. So that takes us to the end of the presentation. So here I have included some additional information on if you like to get started or if you like to explore this further. You can check out our OpenLiberty operator documentation. It has a lot of information, and there's also a blog post. And at the end here, I have included the link for our Liberty images. So let me switch to the browser here. Oh, sorry, this one. Yeah, so this is our GitHub repository that you can go to. This link will be pasted into the chat. And also, we will share the slides with you. Then if you go to the documentation, I just want to quickly show this. So we have different documentation, and yeah, it talks about the samples as well as the installation aspect, the different configurations that you can do. I just touched based on some of the main ones, but you can do things like service binding, or you can configure the service. And for OpenLiberty, we talked about the single sign-on and so on. So all that information is here. And we also have an extensive list of different topics and various samples. So if you'd like to explore this further. And here is some information about the data operations that I talked about. Okay, so over here, just wanted to show you this in action. So here I have an OpenShift cluster. So let me go and so this is the integrated operator hub, and if you go and search in here for Liberty, you should see this OpenLiberty operator. And to install it, it's pretty simple. You just go and say install. And when it comes to install, you have two choices, whether you can install it for the entire cluster, or you can install it to a particular namespace on the cluster. So in this case, I'm just going to install it to this particular namespace demo. And the approval strategy is whether in the future, if there's any updates to the operator, do you want that to be applied automatically, or you want to approve that manually. So I'm just going to leave that as automatic. Oops, I may have deleted the. Okay, let me search. Okay, incorrectly select the namespace that was about to be deleted. So let me try this again. Okay, let's install to default. Right. So installing is pretty straightforward. It just takes a minute or two, and the operator should come up. So in the meantime, let me switch over to the installed operator view. We should already see the operator come up here. It's still being installed, but as you can see, these are the three different custom resources that we talked about, the OpenLiberty application. So this is the main one that you will use to deploy your application, and these are the data operations. So just going to wait a few seconds for the install to complete. Okay, so while it's doing that, let me switch over here. So let's go ahead and create an instance of the OpenLiberty application. So it's very easy to do. So there's a form view as well as a YAML. And we also have a sample snippet to get you started. And this is an application that's a sample OpenLiberty application, the pet clinic application that's being deployed by this. So let me see. Okay, so the install completed. So here is where I'm saying I want to have one instance of my application. But if you want high availability, you can set that to higher. And this is again the setting for the route. So here, I'm just going to say okay, create. And if you go back to the OpenLiberty application, you should see the resources that it created. So it created a deployment, a service, and a route. If you go to the route and see it has pods and is already up and running. So if you go back to the route, so as you can see, this is pointing to the application itself. Okay, anyways. Yeah, so that's a quick introduction to OpenLiberty operator. Obviously, it has a lot of other capabilities, so I would highly encourage you to check it out. All right, so now we're nearing the end of the session. So if there's any questions, we can take them. All right, I don't see any questions at this point. So yeah, so we will share the slides with you, and please try it out. And if you have any feedback, please share it with us. It's all open. It's all in the open. It's a public GitHub repository. If you have any feedback or if you find any issues, feel free to open an issue. And in the presentation, I have included my email address, so you can reach out to me directly as well. All right. So with that, that concludes today's session. Thank you all. Thank you for joining, and I'll hopefully see you in a future session.